All right, we are still in section 3 talking about radians and angles. And so we're going to pick up today with the length of a circular arc, and we're going to talk about coterminal angles. So remember that we said the way that you determine the radian measure of something is that it is R is equal to theta divided by S. So theta is your angle. I'm sorry, we're not solving for R, we're solving for theta. The way that you find the angle, theta is equal to S divided by R. That's the arc length divided by the radius. If I simply multiply both sides by R, then we are left with S is equal to R times theta. And so that's where this formula comes from. It's the exact same formula, just rearranged a little bit differently. So instead, if I know the radian measure of the angle theta and I know the radius of the circle, we can determine the arc length by solving for S. Okay, so here is how this would work. Number 9 says a circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. Here's what's really important about this formula that you want to make sure you notice is that the measure of the central angle must be in radians. This formula does not work with degrees. So in number 9, they've given us degrees. And that's the issue. So it says a circle has a radius of 10. Find the length of the arc intercepted by a central angle of 120 degrees. The first thing that we have to do then is convert 120 degrees into radians. Okay, so we multiply by that factor of pi over 180. And the degrees cancel. 120 over 80, you can divide those both by 60, and we end up with 2 pi thirds. So that is the measure of theta. 10 inches is going to be the measure of R. That's our radius. So to find the answer we want, we have S is equal to R, which is 10, times theta, which is 2 pi thirds, and that comes out to 20 pi thirds. And this is the length of the arc. So that's going to be in inches. And that's a perfectly fine answer to leave it just like that. You don't need to put it as a decimal unless you're asked to. So I would love for you to pause the video, turn the page, and go ahead and try number 10 on your own. Notice this one does ask you to round. So you'll need your calculator, and I'll come back here with the answers in 3 seconds. Okay, so you should get pi fourths for your measure of theta in radians. In terms of pi, your answer would be 3 pi over 2 inches, and as a decimal, that comes out to 4.71 inches. Okay, the last thing that we're going to talk about today is coterminal angles. So two angles that have the same initial and terminal sides, but possibly different rotations are called coterminal angles. Okay, when we do this, the idea and the word itself, coterminal, tells you they have the same co-terminal side. So if I have an angle that measures, let's say 45 degrees, so that would be this angle right here is 45 degrees. Now, if I were to do 395 degrees, or no, 405 degrees, that would be all the way around the circle plus 45 degrees more. So that would look like this, a whole circle plus another 45, that would be 405 degrees. Notice that the terminal side, the arrow part, ends up landing in the same spot. Are those the same angle? No, but we call them coterminal because even though they're different, their terminal side lands in the same place. We could also do this in the negative direction. Let's say that I did negative 315 degrees. I would start at 0 and go around this way, and I would still land in exactly the same spot. So all three of those angles are coterminal. So that means the way that we find coterminal angles is by either adding or subtracting multiples of 360 degrees, and that k just represents any integer. So if k is 2, you're adding 2 multiples of 360 or 720 degrees. If we're measuring in terms of radians, then a full circle is 2 pi. So we would simply add or subtract multiples of 2 pi. Okay, this turns out to be pretty important as we're moving forward because it might be really difficult to know something about an 800-degree angle, but it might be very simple to know something about an 80-degree angle. And since those are coterminal, they're going to have a lot of the same properties that we're going to learn moving forward. So number 6 says, assume the following angles are in standard position. Find a positive angle less than 360 that is coterminal with each of the following. So we either need to add 360 or subtract 360 to get it to a number that's between 0 and 360. So the first one says a 420-degree angle. Well, that's bigger than 360. So we're going to subtract 360 from that, and we get 60 degrees. And that is less than 360. So that is our coterminal angle. That means a 60-degree angle and a 420-degree angle, even though they are different degrees, will land the same spot on the circle. B is negative. So that means that to get to a positive angle, this time we need to add 360 to this. And so we get 240 degrees. Go ahead and pause. Try C and D on your own, and I'll come back here with answers in 3 seconds. Okay, double check to see that that's what you've got. We had to subtract on C and add on D. Okay, number 7 is the same thing. We're just looking at radian measures this time. So same premise, assume the following angles are in standard position, find a positive angle less than 2 pi that is coterminal with each of the following. So 17 pi 6, that's positive, and we know that that's bigger than 2 pi because 6 goes into 17 twice and then some. You have some left over, so it's bigger than 2 pi. So we need to do 17 pi over 6 minus 2 pi, which is over 1. Remember, we need a common denominator here, so we're going to multiply by 6 over 6, which makes this 17 pi 6 minus 12 pi 6. So the answer is 5 pi 6. Okay. B is similar, but since we're starting with a negative, to get to a positive, we're going to need to add this time. Now, you can kind of do some steps in your head. I know that 2 pi over 1 is what I'm going to add. If I multiply that by 12 over 12, I'm going to get 24 pi over 12. So I'm going to kind of do that scratch work off to the side, or maybe even in my head. So we're going to do negative pi 12ths plus 24 pi 12ths. So we see that the answer here is going to be positive 23 pi, 12ths. And we know that that is less than 2 pi because, again, if I think how many times does 12 go into 23, it goes in only once with a little bit left over. So since it only goes in one time, I know that I'm less than 2 pi. So once again, I'm going to ask you to pause and go ahead and try C and D on your own. I'll be back in a second. Okay, so again, we need to subtract on part C and we need to add on part D. So these are the answers that you should end up with. Now, as we've seen, we're not limited to only one extra rotation. We can go around the circle as many times as we want. So if your number is very large, then you might need to add or subtract more than one multiple of 360 or 2 pi, depending on your units. So for A, we're trying to find a positive angle less than 360 or 2 pi that is coterminal with each of the following. So you can kind of think this through. And so for part A, we have 750 degrees. If I subtract 360, You can put that in your calculator. 750 minus 360 is equal to 390. So that's still too big. So then you need to subtract another 360, which means we've ended up subtracting a total of 720 degrees. So we get 30 degrees as our coterminal angle. Now, another way you can think of this is sit with your calculator and start doing multiples of 360. 360 times 2 is 720, which is still less. So that's how you know that that's enough. If we weren't sure, then you would try 360 times 3, which comes out to 1080. That's too big. So you know that you only need to subtract 2 multiples of 360. For B, we need to be subtracting multiples of 2 pi. Now we're working in thirds, so 2 pi over 1 is going to be equal to 6 pi over 3. So we're looking for a multiple of 6 pi that has to stay less than 22. We're working in thirds. So at 6 pi, there's going to be some left over. 12 pi, there's going to be some left over. 18 pi, still going to be some left over. 24 pi, that's too big. So I know that I need to subtract 22 pi thirds minus 18 pi thirds. So that's 3 multiples of 6 pi thirds, aka 2 pi. And we are left with 4 pi thirds, which is definitely less than 2 pi. So pause the video and try part C. This one is negative, so we're going to need to be adding, and you're definitely going to have to add more than one multiple until you get to a positive angle. I'll be back in a second with the answers. All right, 12 pi 6, if we add that, that's 2 pi. If we add that, we still have a negative 5 pi 6. So we know that that's not enough. That's how I knew to multiply it by 2 instead of just 1, and to use 24 pi 6, and that was enough to push me over in the positive direction. So that's how coterminal angles work. That's something we're going to be using a lot. So let me know if you have any questions, and I will see you guys later.